We're going to start off with talking a little bit about combustion. Just really curious, anybody in here, have you already had the gas term? Anybody?
Yes. Yeah.
Okay, what campus?
Waterbury.
Okay, thank you. Okay, so some of the combustion may be a little bit of a repeat for you. The key is in oil. Just remember that we have to take that, before we can burn it, it has to become a gas. Okay, so we have combustion. It's called rapid oxidation. Why am I tossing this name at you? Why do I go through this? Because on state licensing exams, this shows up. Okay, this word, rapid oxidation, will show up on your state licensing exam. It's going to be multiple choice. What is it? It's combustion. It's the burning of a substance. We know that all matter is made up of elements. Okay, one of the most basic elements is oxygen. Okay, many materials react with oxygen. This is why it's called oxidation. Okay, rusting of metals is a common form. Sometimes heat has to be added for this process to take place. And sometimes heat is given off from this process. Okay, when oxygen acts with a substance to produce large amount of heat rapidly, and light as well, it's called combustion or burning. When enough air is present, fuel gases will burn in their normal gaseous state. Again, gases. We cannot burn a liquid or a solid. Solid or liquid fuels have to be changed to a gas first before they burn. I got to add heat to make this transition. Okay, got to add heat. Anytime I'm making a transition from a solid to a liquid to a gas, from a liquid to a gas, I have to add heat. Remember, there's a latent heat happens anytime there's a change of state. Three things have to be available, okay, for this to take place. Fuel, oxygen, which is part of air, and heat. You take away any one of these three items and the burning process will stop. This is called the triangle of combustion. This is really critical, folks, for you guys to know. The triangle of combustion. You should be able to draw this out if you're ever asked to. Okay, we have fuel, air, and heat. You remove any one of these, the combustion process stops. Okay, fuel oil is 85% carbon and 15% hydrogen. Air is 21% oxygen and 79% nitrogen with some other little crap thrown in that really doesn't matter. You're in control of the combustion process because you can regulate both the fuel and the air. Whenever we're working on oil burners, that is what the only two things we can regulate, the fuel and the air. Okay, that's what we're in control of. Okay, so we take a wood-burning fire for an example. I throw a blanket over the fire and cut off the air. The fire goes out. I drag all the wood away from the fire. The fire goes out. I throw water on the fire. We chill the wood temperature down. The fire goes out. Okay? Every one of these examples has something to do with the triangle of combustion. Combustion gives off stuff. We call those the byproducts of combustion. Combustion gives off water vapor. It gives off carbon monoxide. It gives off carbon dioxide. And it gives off carbon. Okay, all of these are byproducts of combustion. Which is the most dangerous byproduct of combustion?
Carbon monoxide.
Yeah, the carbon monoxide is the most dangerous byproduct of combustion. Can carbon dioxide be dangerous as well?
No, or yes. Yes.
It's not as dangerous, but carbon dioxide, if it totally replaces the oxygen content in a room, yeah, it's dangerous. Okay? If you ever feel like you're falling asleep in a classroom with a bunch of people in it after like 3 hours of lecture, might not be the lecture that's putting you to sleep. Might be the fact that everyone is breathing out and exhaling carbon dioxide. Okay, and if there's not enough fresh air coming in, that room suddenly has a lot of carbon dioxide in it. Okay, so again, all of these are byproducts of combustion. You hold your hand over a candle flame, not too close so you don't get burned, but you hold your hand over a flame of the candle. You're going to feel some moisture. Okay, carbon monoxide, I really don't want to have come off a flame, but it's there. Carbon dioxide, it's part of burning. And then you have carbon, which is soot. Okay? The air-fuel mixture must be exact. If the mixture is correct, then proper combustion is achieved. If the mixture is incorrect, you have poor combustion. Okay? As long as we have proper combustion, we get more heat per dollar. In other words, we're burning all the fuel. We have clean exhaust. We have a clean furnace or boiler, and we have proper efficiency. The fuel and air ratio, the mixture between fuel and air, is your most critical mixture. That's your only adjustments. But it can tell the difference between a lot of money being burned, a lot of carbon monoxide, soot, and everything else, or a proper and clean burner. Okay? Less heat per dollar. You're not getting the 140,000 BTUs per gallon. You're getting more soot and smoke, which translates to more furnace or boiler maintenance. Unburned fuel equals poor efficiency and a waste of money. Okay? Fuel oil must be in a vapor form. We've talked about this a lot. Okay? An example of this could be a pot of oil at room temperature. If you quickly dip that match into the oil, okay, and not just light the surface where the vapors are, the oil's not going to burn. It has to be vaporized first. Okay? Oil burner has the primary function of vaporizing this fuel. We have 4 different types of oil burners available. Some of them you'll never see. Okay, you have the pressurized atomizing or gun type. This is the one we've been talking about. You have a rotary cup, you have a vaporizing, and you have a pot burner. Okay, you're never going to see the last one. Okay, the top pot type burner used basically, it looked like a fry pan. Oil valve came in with a sort of a float valve. It had a puddle of oil and it burnt the oil on the top. Basically, the fire just sat on the top and burnt off the vapors. The heat from the fire creates more vapor. These things used to be installed under the floors in front entry homes of houses. Now look at this. Where's the exhaust? Anybody, where's the exhaust?
There is none.
Cannot tell.
There is none. Think people might have died a little bit here? Okay. The carbon monoxide went into the houses. You had to have open windows and good ventilation or you had issues. Gun-type burners, they're the most frequent. They're on all newer equipment. Air and oxygen are forced into the burner head for mixing and ignition. 2 types of gun-type burners, low pressure and high pressure. These are all your parts. By now, you should be able to identify all these parts. Hint, by now, you should be able to identify all these parts. Okay? So in other words, if I gave you a blank diagram and gave you 15 minutes to name all the parts, you should be able to do it. Okay? All of these parts we've talked about. A low pressure type only runs at about 10 psi of oil pressure. Okay? We mix the air and the oil together before it goes through the nozzle. That's a low pressure type burner. You don't see these. They're more in process stuff, more in like making something out of something. Okay, air and oil is mixed together right in the burner tube before it comes out of the nozzle. Secondary air comes in around it. This type of burner is not found very often anymore. The type of burners we are dealing with are the high pressure burners. The oil is forced through by itself and then mixes with the air as it comes out of the nozzle. 100 psi and higher. High pressure gun type burners. Okay, oil supply is much higher. It is the type of most modern burners. It's a high pressure gun type burner. Air is supplied by a burner fan. We've talked about this. Air is adjustable by the burner adjustments. Air is brought into the process from the air surrounding the furnace or the boiler room. It's room air. It's conditioned air. Fuel and air are mixed together by some of these parts: turbulators, end cones, spinners, flame retention heads. All are designed to mix the droplets of oil and air. Now think back to yesterday. What did I tell you about this mixing process? What about the spinning of the droplets in the air? There's something very important.
They rotate in the directions.
Yeah, rotate in different directions. Okay, very important. Poor mixing of air and oil means incomplete combustion, which is smoke. You got a very smoky fire if it's not mixing properly. We have several factors that control this air and fuel mixture. We have to have the spray pattern correct. We talked about this yesterday with our nozzles. We talked about the spray angle being correct. We talked about airflow that has to match both the angle and the pattern. And we talked about the importance of all nozzles matching the manufacturer specifications. Okay, all of this has to do with controlling the air-fuel mixture of the oil. It is extremely important that the oil does not hit the outside of the combustion chamber. It's extremely important that the air-fuel mixture is absolutely correct. The burner design and parts are very important to this process. Okay, flame retention heads. If there's air that internally recirculates, if there's an end cone on the end of this, the air swirl pattern, all of this is extremely important to this air-fuel mixture. Again, there's only two things you can control in an oil burner, okay? And that is the amount of air and the amount of oil. Burner design varies by manufacturer. Any questions on that?
No, sir.
Anybody else? Okay. Now, I talked a little bit yesterday about, I asked a question, can I increase the efficiency of oil boilers as they get older?
No, sir.
Okay. Now, that's not to say that a burner cannot be kept efficient. So as we go through this part, I really want you to keep in mind that burners don't get better with age. I also want you to keep in mind that you are not mechanical engineers, but there are some very simple things that you can do that I would rather this said to keep the efficiency. Okay, but efficiency becomes a big place. Now, this is talking about boilers more than furnaces, but it still involves burners, which is why I even go over this. Okay? We have to keep things clean. Okay? Everything has to be clean. If we have a soot layer, and that's why this is starting to talk about importance, and this is why we talk about annual maintenance. A soot layer, that's a very fine soot layer. I mean, 0.03 inches is not all that great. Okay? It can decrease efficiency by 9.5%. Okay? If I have a 0.18 layer of soot, it can affect efficiency by 69%. Think about that. So a dirty furnace, a dirty boiler, reduces efficiency, and the reason is because the boiler or furnace is not absorbing that heat, it's sending it up the chimney. The flue gas temperature goes up, as does energy cost. So my biggest efficiency thing in both boilers and furnaces, this says boilers, but it's both, keep them clean. Maintaining the system at peak efficiency means keeping it as clean as possible. Deposits on the water side, that's the inside of the boiler, which we'll talk much more about in the future, can also impair heat transfer. Okay? But the biggest issue we have is with the soot building up, and that's on the outside of the boiler tubes. Okay? 1 millimeter of scale buildup in a boiler that's on the water side can increase fuel consumption by 2%. So we basically have a heat exchanger. Okay, think of this wall as a heat exchanger. My fire is on this side of the wall. My water or air in a furnace is on this side of the wall. Anything that builds up on this wall can increase fuel efficiency. Soot, from my last slide, soot can affect efficiency in small quantities, 0.03 inch layers of soot, 9.5%. That's a lot of money. Double that to 0.18 inch of soot, 69% fuel cost lost up the chimney. Okay, so cleanliness makes a big difference. Okay, excess combustion air, I'm going to talk about this. We want to remove unwanted air. We mix air in to our combustion process in exact amounts. So if we have other air leaking in through missing ports, missing covers on observation ports, faulty gaskets, okay, doors not closed properly, things not put together properly, you're going to have excess combustion air. It's going to affect your combustion, and it's going to allow the combustion gases to go up the chimney too fast before all the heat is absorbed. So again, anytime we send that combustion gases up the chimney before absorbing all the heat, we lose efficiency. We measure excess air, and I'm going to talk about that when we talk about our combustion efficiency. Excess air is one of our measurements. Okay, it is one of the major ways our oil burning equipment drops in efficiencies. Too much air increases the fuel gas temperature and drops the efficiency dramatically. Okay, too much air. Now, too little air, what does that cause? What if I have too little air in a system? I mentioned this yesterday. What if I have too little air? What does that cause?
Should decrease, shouldn't it?
If I have too little air, it's going to increase the efficiency drastically, but it's going to cause another problem.
What is it?
What does incomplete combustion cause?
Carbon monoxide.
That's one. What else?
Carbon dioxide.
I'm more looking for a nasty substance that if it gets too bad, it's
Soot.
the apprentice job. That's the one. Okay? Incomplete combustion causes soot. Okay? If I have too little air, I'm going to have a very smoky fire, and I pity the next fool who's there on the piece of equipment. Okay, to overcome excess air, we have to find all the leaks and seal them off with a high temperature sealant. Okay, in other words, if you have the furnace or boiler running in a dark room, you shut off the light in the basement while it's running. Any place where you can see flame, there's a leak. Okay, you've got to seal the leaks. Okay, and the way we do this is we use a high temperature specific high temperature sealant. It's a goop that's high temperature rated, and we seal the air leaks. You should not be able to see the oil flame through any opening other than a small observation port that's covered with a tempered glass when that furnace is running. Okay. The use and sizing of a boiler system. Okay? We talk about load sizing. We give an entire design course on this for a very specific reason. Back in the dark ages, when these furnaces and oil boilers were first being installed, someone stood at the curb and said, oh yeah, this system needs to be 150,000 BTU output. And every house on the street would end up with the same boiler size because the contractor bought them in bulk and put them in. Okay, so now code requires us to make sure boilers and everything are sized efficiently to be the exact size the house needs. An overfired boiler, a boiler or furnace that's too big for the house, affects efficiency. Now, what do you do when you show up on a job and the furnace is too big for the house? What do?
You recommend to the customer that it should be replaced with something more efficient.
Then what is the look on your face when you were told, oh yeah, your company installed this 5 years ago?
Ouch. Yeah, I think that would be the first thing that comes to mind.
Okay. You have to do some research. That's what I'm trying to get across, okay? Just because it's in the house and just because you know it's wrong, okay? It's okay to walk away from it just with a, hey, I need to check on something in the office or check on something with my manager, okay? And we'll get back to you.
Okay.
Because it would be a very bad thing. I've had technicians do this, where they find something wrong in a house, they tell the homeowner, it's worse if they put it in writing to the homeowner, and then all of a sudden, okay, they get a second opinion and find out that the wrong piece of equipment was installed. Well, congratulations, your boss now gets to replace the piece of equipment at his expense.
Man, not good.
Yeah, I mean, he should have done it right the first time, but you got to be careful on that. Just because you find something might not mean it's something to tell the customer right here and now. It might be something to do a little research on so that a plan can be put in place. Okay, a good contractor, if their technician finds something like that, okay, I found it a lot out there that things are installed to the wrong size, even by people I worked for. Okay, but what you do is you come back to the office, you talk to the general manager or the owner, and you say, okay, here's what I found. Okay, this is just never going to work right. This is the source of our service calls. But the problem is we installed it. What are we going to do about it? And a good contractor is going to come back and say, here's how we fix it. Okay? Anybody want to add any thoughts to that? Okay, good contractors are going to follow up and fix these problems. So one of the things you do is make sure that the sizing of the equipment matches the building. Okay, we do a design term. I don't have you guys do all the worksheets and everything in design term just to have you guys do worksheets. There's a reason for it. Okay, a good technician understands the design and the heat loss of a building. Okay, in evaluating boiler sizes, consider current and future heating requirements. This is probably one of the biggest issues that I have seen in dealing with new customers. Okay? One of the biggest problems is the sizing of equipment based on current and future heating requirements. Okay. I don't think anybody in here on this call is, other than Mr. Smokers, from the Pennsylvania direction. Most of you guys are in Connecticut. Take a cold winter day. Okay, cold winter day. Let's say January 1st. Okay, and everybody's home. Everybody's sleeping off their New Year's Eve. And everybody starts getting up and using showers, someone starts cooking, using dishwasher, starts running water and stuff like that. If you have a boiler that's also the hot water heater, what happens to the load on that piece of equipment?
Would it increase because everybody's using it at the same time?
Yeah, it's going to go way up. Okay? Now, a year later, someone has decided to remodel a master bathroom because they have nothing better to do with their money for Christmas. And they've added a big old jacuzzi tub. 300 plus gallons of water every time they fill that thing. Okay? Happy homeowner, while their kids are cooking them breakfast, hops in the jacuzzi tub. Is that boiler going to be sized appropriately anymore?
No, thing will be too small at that point.
Okay, so you get a service call that you're the on-call guy. Okay, you get a service call from a very pissed-off homeowner that says, my water isn't heating properly. You walk into the basement, the boiler's running, but everything measures out correctly. How do you find the problem?
Look at their appliances.
Well, this is why one of the first things, which is, your answer is sort of correct, okay? You have to look at what has changed. Okay, one of the first questions, whenever I go into a house on something like this, one of my first questions is, what has changed in the house? Or even more non-threatening is, you know, I'm noticing something different here. Have you guys done any remodeling or anything on the house in the last year since I've been here last? That's a very non-threatening approach to saying, what has changed? Okay? Because the very important question is, what has been added to the house? This happens also when you have situations like somebody added a sunroom. What has changed? It's great if you can see it from the street, but a lot of times you can't see it. And in the basement, you're not going to know that somebody remodeled the master bathroom. All you're going to see is that the boiler is running properly. You can always ask the customer, hey, what has changed? Don't say everything's running right, I need to know what else has changed. Just ask, has anything changed in the house? The homeowner will tell you. They're proud of this stuff. What has changed in the last year? Okay? And again, you have to look at the appliances. What has changed? But again, all of this is future and current and future requirements. The best way to get the most out of oil-fired equipment, have it serviced on an annual basis. Service consists of cleaning the flue passes with a brush or vacuum, change the nozzle, change the filter, change the pump strainer. Sometimes flush out the oil line. I don't 100% agree on that one, but they have it on there for some reason. Okay, but change the nozzle, change the filter, change the pump strainer. So, by the way, when I ask a question that says, how often do you change the oil filter? What's the correct answer?
Annually during service.
Annually. Okay, that's the oil filter. A lot of you guys, I did put some comments on that assignment you turned in. I did make some comments on there, okay? A lot of people were thinking air filter, which could be between 1 and 3 months. You're not going to change an oil filter between 1 and 3 months. So again, just take a look at my comments that I made on the assignment. Okay, that's how we can keep efficiency up going. Now, what is the most important thing people can do on an annual basis when they have oil? What's the whole premise of an oil system?
Making sure you have enough oil in your tank.
Well, making sure it's serviced annually. Okay, I've seen people who ignore their oil equipment and come out and do annual cleanings maybe every 4 years. Well, those things are nasty by then. Okay, oil equipment has to be serviced on a yearly basis. Okay, I don't care what time of year it's done. It doesn't have to be done right before heating season. It doesn't have to be done middle of heating season. It's a annual cleaning. Okay, a lot of oil companies do these in the summertime when they're not delivering oil and not busy with heating calls. Okay, every manufacturer has its own recommended procedures. What I'm going to give you here is called a rule of thumb. Okay, for lack of manufacturer directions, this is what is involved in an annual tune-up. Okay, we start off with the customer contact or interview, we call it. In other words, hey, I'm here to do your annual cleaning. How's it going? Anything I need to know about? Hey, have you noticed any strange smells? Have you smelled oil? Have you smelled any type of anything else that's unusual coming from the basement when the system's running? Okay, because that's what your customer will know. Any strange noises. All of this tell you if there's going to be anything that you need to look specially for. The next step of the annual cleaning is to check the system. Okay? Why do I check this system before I start anything? Anybody? Why do I check this system before I start anything?
Make sure the system is functioning properly.
Well, yeah. How many times, I can't count the number of times where I was sent out to do an annual cleaning and you show up on the job site and the system is not running and they're trying to get a service call out of the annual tune-up price. If you do not check this system before you start your annual maintenance, and if it isn't running when you're done with your annual maintenance, in other words, if there's a bad part or something, you have no choice but to replace that part courtesy of your company. Okay, because you will never be able to prove that you didn't break the system. So it's extremely important that you check that system and make sure it's operational before you start your annual maintenance. If it's not operational, your contractor, the guy you're working for, the company you're working for, will have procedures in place to deal with how you deal with a non-operational system. Okay, my frequent way to deal with it was, hey, listen, the system's not working. This probably should have been a service call, but I'll tell you what. I'll handle it under the annual tune-up. However, any parts that are bad, you will need to replace as an additional cost. But I can save you the cost of a service call if you accept a contract for annual maintenance. Okay, so I was always given the freedom to turn it into a preventative maintenance contract sale. So, but every contractor is going to have a different place. If you get to this point and the system is not running, okay, where do you start every service call? What's the first thing you look at?
Thermostat.
Thermostat. Do not go further than the thermostat. And you do your customer interview or the customer conversation while you're walking to the thermostat. Hey, Mr. Smith, I'm here to do your oil burner cleaning. Hope it's okay that we walk through, but can you show me where the thermostat is because I need to make an adjustment before I go to the basement. Okay? So again, and then you have your conversation while you're walking to the thermostat. Okay? Then you clean the system. The next whole part of this is you clean the system. Then we do a combustion efficiency test. I'll talk more about this. Then you clean up after yourself. Then you do a final check of the system. Where is the customer involved in this process if you're a good service technician?
Walk them through everything that you just did or found, and I guess.
Okay. What points of this process is a customer involved if you're a good service technician?
Out of the way?
All of them. I don't want that customer out of the way. No way. I want that customer with me. Okay? Once you're in the field, you'll understand what I'm talking about. I want that customer with me. I want them to see me check their system. I like to see them on occasion poke their head in while I'm cleaning the system. I want them to see me doing the combustion efficiency test. I want them to see me making my adjustments. I want them to know that I've spent the time to clean up. And I want them involved with me in the final check of the system. That's their checkpoint. It's running. It's clean. I've changed the filters. Why do I want the customer involved with me as a service tech all the way through? There's no wrong answer here, folks.
To let them know you know what you're doing?
Yeah, I'm building credibility, aren't I? Through this entire process, I'm building credibility. Too many of the older oil burner techs come in, grunt at the customer, walk to the thermostat, turn it down because they've been there 100 times. They go to the basement. They say, I'll see you about in an hour. They go down. They do this whole thing. They don't necessarily clean up after themselves. They go back out to their truck, write up the paperwork, come in and present the customer with a bill. Is there any credibility that's built through that entire process?
No, the customer won't even know if you actually did any of that stuff that
Well,
they're being billed for.
Yeah, but here's the thing. You as a technician have the greatest credibility when the customer sees you work. Why does that matter? Okay? This goes a little bit outside the technical stuff we teach, but this is all with job-related stuff we teach. Why does your credibility matter?
They'll see you work well and then transfer them, but hopefully get more business.
Their system's going to die eventually, right? Everybody realizes this oil furnace is going to fail eventually, right?
True.
Who has more credibility, a technician who's been taking care of the customer and really is involved with the customer, or the sales guy who comes in when a system dies? Who has more credibility?
The technician, if he was doing his job right.
The technician always has more credibility as long as the customer knows you are doing your job. So when you're working for a company as a technician, you are the one who is out there when that furnace or boiler dies. You are the one that has to say, you know, Mrs. Smith, we've been servicing this for maybe the last 6-7 years, and it's a 1983 piece of equipment. Yeah, I graduated from high school about then, but it's probably time for this piece of equipment to be replaced. Okay? Would you like me to give you a quote, or do you want me to call a salesperson? How powerful is that statement?
Very powerful, actually. You're not even threatened by the salesperson.
Is any customer going to say, yeah, call a salesperson?
If they're shopping for the right price, yeah.
But if they trust you as a technician, are they necessarily going to shop for the best price?
Not really.
Okay. You can 9 out of 10 times, while you're on the job site, write up a quote if you know what you're doing, if you've paid attention to a lot of the other stuff we're giving you, the tables, the charts, and everything else. You can write up a quote, and you can close the sale right there for a new piece of equipment, and you can have the install team there later the same day or the next day, depending on your company, and there's no chance that that customer's going to go price it around as long as you're fair on your pricing and honest on system replacements. Why do I care about trying to get this through? Why do I spend the time on this?
Keep your customers happy.
Yeah, I want you guys to go into the field and keep your boss's customers happy. There's a little bit of a financial outlet of this. Most of the contractors you work for are going to give you a commission based on that equipment sale. If you can sell a piece of equipment on your own without getting the salespeople involved, size it properly, draw the proper diagrams, take the proper pictures, and have everything ready to go for the installation team, you will probably get some sort of bonus or some sort of commission. The company I worked for the majority of the time I was in the field, I got a 10% commission on equipment sales, as long as I did the entire process and didn't involve a salesperson. It made the difference between my salary of $58,000 a year and my take home, which in my last year in the field was $96,000.
Nice.
Okay? That's why I spend the time on this. It's important. It may not seem important because, hey, it's not it's not system related. It's not how to fix the box. But it's stuff I want you to keep in mind. Depending on the company you're working for, okay, you should be looking for opportunities such as add-ons, such as indoor air quality equipment, such as energy-saving add-ons. And the biggest one ever is maintenance plans. All of this you cannot sell to a customer if you don't have credibility. All of this, most companies will give you some sort of spiff or bonus on, as long as it's done honestly. Okay? I know a technician who added about $100,000 a year to their income because of energy efficiency add-ons and stuff like that. So, I mean, I feel very strongly about that. Do it right, involve the customer, you will make money. All of your time spent should be spent cleaning and adjusting the equipment and educating the customer. There is an opportunity to be in contact with the customer when there's not a problem. Preventative maintenances, annual tune-ups are the only time you are going to be in contact with the customer when there's not a problem. Okay, in other words, you have a customer who's thankful you are there in front of them because you're taking care of their equipment and they're not going to have a no heat situation. Happens very infrequently. Upon arrival with the job site, spend a few minutes with the customer. Ask about unusual sounds, cold spots, fuel usage, strange smells, any concerns or anything they want you to check. Ask the customer to show you all the thermostats in the house. Don't assume there's just one. Check each thermostat. If it's a mercury thermostat, check it with a level. Okay, and since I'm there for not a service call, I'm going to recommend that customer replace any mercury thermostat with a digital thermostat or snap acting. Okay, I'm going to make the recommendation right there as I'm walking through the house. Hey, you know, this thermostat has mercury in it. We're just recommending to everybody that we replace these. If you want, well, before I'm done today, I'll give you a quote. Turn all thermostats up over room temperature by 10 to 15 degrees. In other words, the system's going to keep running while I'm in the basement. Ask the homeowner or the customer to take you to the furnace or the burner. Explain to them what you're going to do, how long it will take. Ask the customer the best route to get in and out to your truck since you're going to be carrying oil and supplies. Try to use an outside door or basement hatch. You don't want to walk across the customer's white carpet. Okay? And if your dispatcher was a good dispatcher, they actually had told the homeowner you're going to want an outside entrance before you showed up on the job site, so you won't have to break out the trusty snow shovel and shovel yourself a path. Okay? If the dispatcher was a good dispatcher. Offer to show the customer what you're doing. Most will say no, they'll see you when you're done, but offering the customer to stick around and see what's going on. Okay? Builds credibility. You're not hiding anything. There's no mystery. Again, don't be the guy who grunts at the customer and walks to the basement and sees them an hour and a half later. The furnace or boiler should be running at this point due to turning up the thermostats above room temperature. Check to see if there's any signs of problems like smoke, oil leaks, or water leaks. Okay, again, you still have the customer with you. If that furnace is not running, okay, if that boiler's not running at this point, we have a problem situation. Again, oil leaks. You just want to do a quick walkthrough while that customer's with you. You can ask the customer, hey, has this water been here for a while? Or when did this start? Hey, I smell a little and see a little oil leak here. When did this start? Okay, you're acknowledging the customer that there's a couple problems you have spotted off the top. So there's no question ever if you caused the problem or not. Check anything that the customer may have complained about during your initial conversation. You want to note any of these problems on your service ticket, okay? And anything that's not repairable as a part of your preventative system service, you want to give the customer a price to repair. You can't replace and repair everything as a part of your preventative maintenance call. Your employer is going to get pissed with you if you do that, okay? Some of this stuff is a service call. If I have an oil leak around a filter that I'm going to change anyways, hey, yeah, I could probably fix that oil leak when we do the filter, when I change the filter. That's part of your service call. Okay, you're building credibility. But if I have an oil leak in the middle of an oil line at a connection, hey, we're going to have to, this oil leak, I have to do a service ticket on this one because this goes outside the scope of the preventative maintenance. Okay? All of this stuff is income to your boss. While the burner is still running, you're going to close the firematic valve next to the oil pump. You're not going to close the one at the tank. The burner is going to start to lose oil pressure and then lose flame due to lack of oil. The primary control should trip out, okay, at the time that's written or stamped on the control. What have I just checked the operation of? Right here, what have I checked the operation? Folks, what have I checked the operation of right here?
Your stack switch?
Yeah, either my CAD cell or my stack switch. I've verified that my safety works. So I've done step one of my preventative maintenance. I know that the safety works. I also know that that valve works. Okay, what else have I accomplished? Do I have any more oil in that pump? No. I don't have a ton of oil in that burner anymore at this point. Okay, now I'm going to turn the service switch off. Okay, if it's a forced air system, I'm turning everything off. If it's a boiler, I want to leave the water circulating in the system. In other words, I don't want to turn the main power off. I'm just going to turn the power to the burner off. Usually there's a plug you can pull. Okay, all I want to do is disable the burner. I want to leave the water circulating because I want it to cool down. Then I'm going to turn off the oil valve that's next to the tank filter. There's a valve between the tank and the filter. I'm going to close that. I'm going to put a pie plan, or lack of anything else, a frisbee, believe it or not, under the oil filter. I also use oil-absorbent pads as well on the floor. You're going to slowly unscrew the oil filter and allow the oil in the filter to spill into the pan. You're going to change the filter. Okay, if it's a cartridge filter, make sure you change that gasket as well. Okay, clean all the sludge out of the filter if it's a standard filter where you're just replacing the insides. I showed you that yesterday. After putting the filter back on, check to make sure all gaskets are in. And there's only one gasket around the filter. It's very easy to forget and put a second gasket on the filter housing. Talked about that when we talked about filters. Turn the oil valve back on and bleed the air out of the filter. Check for leaks and wipe any extra oil off. Did I remove any of my drop cloths or anything by this point? Or are they all still there?
They should all still be there.
That's correct. Oil on a concrete floor, you will never get the smell out. Okay? And some customers are very sensitive to the oil smell. Leave a clean absorbent pad under the filter. You'll let the customer know when they can remove this later. Okay, it's okay to leave a clean pad and tell the customer, hey, leave this leave this here for about a week. Let us know if there's any drops of oil on this. You can toss this away after a week. It can just go in the regular trash. Okay? Because the customer knows you care about their floor. You want to know if there's a leak. Okay? I always leave one in place. 9 out of 10 times the customer won't even remember that it was there, and it will be there the next time you come. Go to the burner. Remove the nozzle assembly, being careful not to drip oil on the floor or on the burner. Take the nozzle assembly, the old oil filter, and any spilled oil out to your truck. Okay, in other words, I'm cleaning as I'm going. I'm getting any old, loose oil, any parts that could roll around, I'm getting it out to my truck. I have the nozzle assembly, the old oil filter, and the spilled oil. I've now gotten it out of the house. The reason I do this, it's very easy to step in something you didn't mean to step in. Remove the nozzle from the assembly. Do this at your truck. If there's going to be a bunch of cursing and swearing going on, you don't want to do it in the customer's house. Check the filter on the nozzle for any signs of metal shavings from the pump. Remove the electrodes and clean all signs of carbon off of them. Check the tips of the electrodes. If they're worn, they get replaced as a part of the annual maintenance. Okay, save your parts. Don't toss any parts around. You want to show the customer the old and the new. Okay? It's very easy. You show them the old ones, you show them the new ones installed, and say, hey, listen, this is part of your preventative maintenance, but I just want to let you know we did end up having to change the electrodes this time. Okay? Again, important. They need to see you did the work, especially if you can show them something good that they're paying for as a part of their maintenance. Reassemble the nozzle assembly. Replace the nozzle with a new one of the same size, spray pattern, and angle. And again, check the furnace tag to make sure the guy before you didn't use the wrong one. Replace the electrodes and adjust them using the electrode adjustment gauge. When you get into shop, you're going to practice with this and you're going to wish you had a third and fourth hand. Do a final wipe down of the nozzle assembly. When you go back in the basement with the nozzle assembly, you're taking your soot vac back into the basement with you. Now, what are you going to use to clean the nozzle assembly?
A clean, soft rag?
Yeah. Okay, you're not going to use sandpaper. You're not going to use anything with a rough surface. There's a chemical that you can use that's actually a great chemical. You can find it in any place in the world. Okay, any home improvement store has it. It's called lacquer thinner. Okay, lacquer thinner will take the soot and the carbon buildup off of anything. Okay, it's great to have on your truck because it actually works very, very well and it will not hurt the surfaces. Lacquer thinner. Okay, back in the basement, you're going to replace the nozzle assembly. You're going to change the pump strainer. If you have a Webster pump, that's a brand of pump. You do not change the strainer. They grind stuff up. They don't strain it. They have grinding gears in it. If you open the cover on a Webster pump, you're going to have a handful of gears. Bad things happen. Okay, reassemble the burner, and on all equipment, make sure the service switch is off. Do not open the firematic to the pump yet. Okay, so you're reassembling everything, but you're not turning it on yet. Remove the flue pipe. Okay, you're going to remove the flue pipe from both the chimney and the piece of equipment or the power venter connector. You're going to gently tap the flue pipe on a drop cloth. What that does, it takes any residue out. You're going to vacuum that up using the soot vacuum and put it aside in an area where it won't get damaged. When you're tapping that flue pipe onto the drop cloth, you're doing something else that's extremely important. What are you doing? Somebody knows the answer to this. What am I checking when I'm tapping that flue pipe?
Well, you got your residue.
What am I checking when I tap that flue pipe on the ground?
Make sure it's getting hot.
Well, no, because it's really turned off, but I'm making sure. When you have metal, that comes in contact with moisture, what happens to the metal?
Ooh, rust?
It rusts. One of my byproducts of combustion is what? Come on.
Vaporization?
One of my byproducts of combustion is water, right?
Right.
Okay, so I'm putting out water vapor into a metal flue pipe. Where is that flue pipe going to rust, on the inside or outside?
On the inside.
Okay, so if I don't take that flue pipe off, and all I do is look at it from the outside, will I see that if it's almost rusted through?
No.
No. Okay, so when I pull that flue pipe off and tap on it, if I see a ton of rust or if it feels flimsy to me, you will actually feel it if it's about to start breaking. It's not going to stay as a circle. It's going to start shifting on you. It's going to feel like aluminum foil. Okay? I'm doing a safety check to make sure that that flue pipe is still good. I've actually gone into a basement and grabbed a flue pipe in a preventative maintenance, pulled it off the furnace and off the chimney, tapped it, and it fell apart. Okay, you don't want that to fall apart while someone's kid accidentally bounces into it or just collapses on its own. People can die with the carbon monoxide. Okay, so just always check that flue pipe. Open up the heat exchanger or the top of the boiler. You're going to use brushes to completely clean the inside of the boiler or heat exchanger, depending on what piece of equipment you're on, and you're going to vacuum it out. You're going to open the combustion chamber. You're going to carefully vacuum out any residue. You don't want to damage the inside of the combustion chamber. Don't be an apprentice named Joe I had about 20 years ago. Okay, I left Joe on a job site, and because I figured by that point he would be able to manage cleaning a boiler. Okay, simple job. Figured he'd be able to, since he watched me do it for about 6 months, I figured he'd be able to clean the inside of clean a boiler. I left him with the tools, left him with the soot vac, left him with the brushes. He was so proud of himself when he cleaned the inside of the boiler, and he told me he got all the white buildup out of the boiler. Okay, white buildup. I sort of was like, okay, that boiler was like cleaned 6 months ago. It was for a restaurant, and there shouldn't have been any buildup in that boiler. So I said, show me the inside of the soot vac. It had white fiberglass all over the inside of the soot vac, sort of a white material. He had actually vacuumed and cleaned the combustion chamber right out of the boiler. Okay, don't damage the combustion chamber. And yes, there was a whole bunch of cursing and swearing that went on. Okay, reassemble the furnace and put the flue pipe back on. Check and make sure that all screws are replaced. How many screws should be in every connection of a flue pipe?
4. Wild guess.
Well, I like 4 better, but the reality is, if you have a connection of a flue pipe, you have to have a screw there, you have to have a screw there, and you should have a screw someplace over here.
Okay, I was close.
That makes sure the flue pipe cannot bend. If I just put 2 screws in a flue pipe, there and there, it can wiggle up and down. If I just am lazy and put 1 screw in a flue pipe, it's going to fall apart. Okay, all 3 screws at a minimum, and by the way, that's code. On a forced air system, change the filters and check the blower assembly. Take your soot vac, old parts, and all the trash out to the truck. At this point, you are now done with the cleaning. All oily and sooty parts are away from the equipment and back out of your truck. You have no chance of making an unintentional mess or leaving something behind that's going to piss the homeowner off. Okay? Connect a vacuum gauge between the oil supply line and the pump. Remember, you didn't open any valves yet. So you're going to open the Firematic next to the burner and leave the one closed at the tank. You're going to turn the vacuum gauge on. The pump should be able to pull a 10-inch vacuum. What have I just checked? What have I just checked by doing this extra vacuum step?
For leaks.
I checked for leaks. Do I know that my oil supply line between the tank valve, including the filter, and the burner don't have any leaks at this point? Yeah. It was able to pull a vacuum. Turn the burner off, the vacuum should hold. If you cannot pull a vacuum and the vacuum does not hold, there's an oil leak. Don't be an idiot. Find the leak. Don't leave a house ever if there's an oil leak. Turn the Firematic off next to the burner and remove the vacuum gauge. Double check all lines and fittings. Check to make sure the smoke pipe is connected and then proceed with system startup. To start the system up is a really great procedure. Turn the Firematic next to the oil pump back on and check to make sure you've opened the valve to the oil tank. Attach a hose to the pump bleed valve. Have a jumper ready for the primary control. Turn the service switch back on. Once the burner starts, jump the FF terminals to leave the burner running. Open the oil bleed valve and bleed oil into the pan until it runs clear. Air in the oil will show as a milky substance. Close the bleed valve and remove the jumper. Burner should now be running normally. You want to go back and again check for any oil leaks all the way along the fuel path from the tank to the nozzle assembly. Okay? You need to fix any leaks found. Wipe down the entire system, make it look clean. You can have done a wonderful job on the inside of the burner, but that's not what the customer sees. Even if you didn't make the mess, clean it. Takes 5 minutes. Shut the service switch off, remove any remaining tools and parts, and get your combustion efficiency kit. The final portion of the tune-up is the combustion efficiency test. You need several tools to do this. You need a smoke tester with little paper strips. You need a draft gauge. You need a carbon dioxide test kit. You need a stack thermometer. Sometimes these two components now are part of one digital set. Okay? Start the furnace or burner again by turning on the service switch. Wait 5 minutes. You want to check our draft. There's a 1/4-inch hole in the flue pipe. You have a draft gauge. Okay, it's below the barometric damper, and it's above the breech. That's the connection to the furnace. You want to be as close to 12 inches above the furnace as possible. The draft gauge, when on a level surface, should have a draft reading between negative 0.04 and negative 0.03 water column. In other words, the chimney should be pulling. Okay? It should be pulling the smoke out of the furnace or boiler. If it's not in this range, adjust the barometric damper so it gets in this range. There's an adjustment on that damper. Remove the draft tube from the hole in the flue and check the draft over the fire. And again, your instructor in shop is going to show you this. The over the fire draft should be between a negative 0.01 and a negative 0.02. Now again, there's some high efficiency equipment out there that might have special instructions on this one. So always look at the manual. If not, we're going to check the air, the venting, and the heat exchanger. If you have 0 over fire draft, you missed a clogged heat exchanger. Go back and clean it again. Remove the draft gauge. You're going to use the smoke tester with a clean piece of test paper. It's a little piece of paper that you put in. It's almost like a paper towel. Okay? What it does, it pulls the air from the flue pipe through the clean piece of white paper. You're going to pump the smoke tester 10 complete times slowly. You're going to check the paper for smoke. You have a chart that comes with this thing that shows you the different colors to identify the level of smoke. 0 is the best smoke, okay? You want to use the primary air adjustment on the burner to adjust it to a 0 or just a trace of smoke. The less smoke, the cleaner the burner is running. Anything over a smoke level of 1 is not acceptable. Don't go any further with your testing until the smoke is cleared up. There's a number of reasons for this. First of all, nothing you adjust further in your testing is going to work properly because your smoke isn't cleared up. The second reason is your digital combustion tools, if you have anything over 1 of smoke, okay, anything over just this little trace of smoke, it's going to break your combustion tools. They cost like $2,000 a piece. You don't want to go there. Okay, so clean up that smoke before you go any further. You're going to use your carbon monoxide or carbon dioxide tester. Put the tube into the hole in the flue pipe. You're going to pump it a few times to prime the tube. Now this is for the older style testers. It has a fluid level in it. You're going to make sure the CO2 tester is calibrated for 0. You're going to push the tube into position on the top of the tester and pump it 18 times. By the way, guys, State of Connecticut exams is still asking for this. How many times do you pump the CO2 tester? It's 18 times. It is still on the licensing exams. How many times do you pump the smoke tester? 10 times. Those two numbers appear on every license exam I've ever seen. They still have not accepted that most of us are using digital tools. Remove the test tube from the top of the flue pipe and release it from the top of the tester. You actually flip the tester over and you observe where the liquid level's off at. That's the number you write down. That's the percentage of carbon dioxide that's in the flue. The next thing you're going to do before you do anything else, you're going to put a thermometer into the flue and you're going to get a temperature reading. You're going to subtract the room temperature from that temperature reading to get your net stack temperature. In other words, if my basement is 75 degrees, okay, that's a 75, and if my stack temperature is 400, okay, my net stack temperature, the number I'm going to work with, is 325. Gotta know what the net stack temperature is. So now I have two numbers. Okay, I have my efficiency, I have my carbon dioxide, and I have my net stack temperature. Use the temperature reading and the carbon dioxide reading, and that will give you your equipment efficiency. Couple rules of thumb. The flue temperature has to be over 250 degrees and under 550. Carbon dioxide should be about 12%. If it's over that, open the air shutter to increase the combustion air. If it's below that, close the air shutter to cut off some air. Carbon dioxide should be about 12%. Once you do these air adjustments, you have to retest. Okay? Combustion efficiency can be compared to prior service records. We hang these tags on the furnaces. But it is what it is. Don't attempt to increase efficiency by altering nozzle sizements or other adjustments. If you have no smoke, proper draft, and proper carbon dioxide, the efficiency percentage is true. The numbers will change with weather conditions and age. They're not the same every year. If I walk into someone's basement and I see 92% efficiency on an oil furnace year after year after year, there's a problem. Because A, an oil furnace that's piped into a vent pipe, into a chimney, that's not using PVC vent pipes cannot be 90%. And B, they will not be the same every year. Someone's just filling out pieces of paper. Okay? Once you're done, you put a 1/4-inch bolt back into the flue pipe to seal it for future use. You record all your numbers on the furnace tag and your service ticket, and you wipe down the equipment. Check and make sure you have all your tools. Anything you moved while you were cleaning the furnace, if you have to move like the laundry rack, a table, or anything else you moved, you have to put it back to where you got it. Don't leave the homeowner with anything to do. Find the customer if they're not with them and ask them to inspect your work. Show and explain the combustion efficiency tag and ask that they check the absorbent pad you left under the filter for leaks. Let them know to call you if there's any leaks suspected. If not, they can throw the pad away in a few weeks. I guarantee they won't remember. Okay? Ask the customer to take you back to each thermostat and turn each thermostat back to the customer's preferred setting. You don't want to leave the customer to do anything else. Have I gone back to my truck yet here?
No, not yet.
Okay. Next step, take your tools with you to the truck to complete the paperwork. Anyone know why I stress this? Take the tools with you to your truck and complete your paperwork.
You don't want to have to embarrass yourself by knocking on the door and asking for your tools.
Well, you're going to go back anyway. You're going to go back anyways because you haven't given the customer the paperwork yet. But why do I want my tools with me when I go back out to the truck?
Just making sure you're not leaving anything behind.
Well, there's a major reason here, okay? At this point, the customer knows you are done with your preventative maintenance, okay? So once you leave, you are trusting them to let you back into the house to A, give them their paperwork, which 9 out of 10 times will include a bill, and B, that you can get your tools. I have seen a situation here where customers, especially first-time customers, don't want to pay that bill. They're never going to answer their front door when you bring it back to them. Guess where your tools are?
Inside the house.
Yeah, causes a problem. Okay, so once you're done with your service call and you're going back out to your truck, if you have to go back outside to complete your paperwork, take your tools with you. It might never happen to you in your entire career, but once it happens, you will never let it happen again. Okay? Walk the customer through your paperwork, get a signature, and get payment. Okay, as a final step, ask the customer to let you do a final walkthrough on the equipment. Quite honestly, the only reason I'm going to do a final walkthrough on the equipment is I want to make sure I didn't leave anything down in that basement. What is one thing that I'm going to specifically check for other than my tools? There's one thing that I'm going to check for. What is that one thing I'm going to check?
Leaks.
Gauge.
Now, I've already checked for all of that. What did I put on to that oil burner control before I started the equipment?
Jumper.
That jumper. I'm going to make sure that that jumper's off that CAD cell relay. Okay? Seriously, you have to remember to go back and pull that jumper because I guarantee you're going to forget it. Okay, because by now your service dispatcher is already calling and yelling at you that you're slow and you should already be done with that job on your way to the next one. Okay, so make sure you go back and double check to make sure you pulled that jumper. Because no matter everything you do, every bit of customer goodwill that you have set up, okay, will vanish if you get the no heat call later because that jumper's still on the system. Okay? And do I feel bad if the customer didn't let me back into my house to get my tools and that jumper's on that system?
At that point, no.
At that point, that's karma. Okay? Make sure all jumpers are removed, valves are open, and switches are on. If you messed with any zone valves, we'll talk more about that when we talk about boilers. If you messed with any zone valves, you got to check them. Did the burner shut off when the temperatures were turned back down? Okay, again, check and make sure that the system's satisfied. Thank the customer for the time. Tell them you'll see them next year. Ask for referrals to neighbors. Ask for permission to have the office call them in a month for a follow-up. The office is going to call them anyways, but it's always nice to ask permission. Hey, can we give you a call just to make sure in a month or so it's working properly? Okay, standard procedure, most offices will call anyways. But that's a preventative maintenance. How long do you think that process should take?
30 minutes to 40.
Anybody else? I know somebody here has worked with oil burner techs. I forget who it is. How long did you if you're on the call, how long when you followed an oil burner tech around, how long did they spend doing an annual tune-up on any oil furnace? Okay, maybe not be on the call.
I don't know. It was about an hour, more than an hour.
Yeah, it's a little bit more than an hour. Probably hour,
I'd say like hour and a half, maybe.
Yeah, if you are out of an oil annual maintenance call in under an hour, you have not done your job. Okay. Knew some techs who were really, really proud of themselves getting in and out of oil burner calls after 45 minutes. Guess where we spent the majority of our time doing after-hour service calls? In those houses. Okay? So again, just hour 15 minutes, hour half, that's about right for an oil furnace. Oil boiler may take you a little bit longer. Okay? Any questions on anything I went over today? This is sort of important, okay? I mean, this is basically what you're going to be doing in the field.
No, sir.
Okay. When you get out on your first job, if you're doing oil, and you can't avoid oil, by the way, in Connecticut. You can't avoid oil. It's there. It's there to stay. There's areas of the state where they're not even going to put natural gas in. There's areas of Hartford they don't put natural gas in. Anything where there was a bus line back in the 1950s, the gas company doesn't want to run gas lines because there's thick concrete under those streets. The gas company doesn't want to go under those streets. Okay, so there's areas that are going to be stuck on oil. There's areas you can't install propane because of distances to electrical outlets, to property lines and stuff like that. There's areas you can't put propane. So oil is here to stay. Okay? The licenses that allow you to work on oil is basically any license with the exception of the D license. D as in David. You can't do oil. Okay, the S licenses, the B licenses allow you to do oil. Everybody in here should have a concentration of striving to get to their S2 license. That's the unlimited journey person's license. That means you can work for a contractor and you can basically work on any type of equipment. S2. That's your goal. Anything less than that, you're cutting yourself short. Okay? Some of you may need to work for a contractor that only has a B license or something like that, but your end goal should be to get that S license. Okay? I think if nobody else has anything, that is basically all I have for today. Anybody else have any questions?
I have a quick question.
Sure.
You opened up the quiz. I'm not sure if you talked about that. For
the week 1 quiz?
Yeah.
You've had all the information on this, okay? Just answer the questions because I think we've talked. I went through it last night, and Spray angles we've talked about. What should never be done, we've talked about that. Type of tank, we've talked about that. It's in your readings. What do the tanks where do the tanks fail from? We talked about that. I think it's 10 questions, and I actually think we've talked about everything in here. So
Okay.
you can go ahead and, yeah, we've talked about this, and it's gauged metal. That was definitely in your readings, and I think you had another question on it as well from your lab. So, yeah, you guys could take that. That's why I opened it, because we've talked about everything there at this point.
All right, sounds good.
It does have a time limit on it, so when you open it, please try to do it in one setting, because the time will expire even if you close it and walk away from it, okay?
All right.
Anyone else?
No, sir.
Okay, thank you, folks. And again, no online session tomorrow. Be involved with career services if you get an invite. Other than that, please get your work caught up and turned in. I'm giving you plenty of time, and we will see you on Monday. Thank you.
All right.
Have a good day.
Take care.
Quarter Riva out. Mike.